We're looking at example 23 on page 126. I'm going to show you lots of steps as you go through, and remember that in order to show that you understand all the little tricks and rules of algebra that you know about logarithms, you need to show those steps systematically. Here we go. So 8 to the power of x subtract 5 multiplied by 4 to the power of x equals 0, and we need to solve exactly. What does this mean? Solve for x exactly. We need to show it in an exact number and not a rounded decimal number from a calculator. All right, so right away from chapter 3, when we were factoring exponentials, we noticed that this number 8 as a base and this number 4 as a base share a base that we could represent as 2 cubed with a base of 2. So 8 will be 2 cubed. I'm just going to show that base of 2 for now. 4 is going to be 2 squared. Okay, so that's the only thing I changed so far. Just change the 8 to 2 cubed, change the 4 to 2 squared. Okay, let's keep working with this. This means this could be 2 to the power of 3x, and this is 5 multiplied by 2 to the power of 2x, and that equals 0. Okay, well, we actually could represent this guy, 2 to the power of 3x, as 2 to the power of 2x multiplied by 2 to the power of x. If you just think about that, if we were going back this other direction, multiplying the same bases and exponents, we keep the base, add the exponents, so 2x plus x is 3x. So that means we can actually separate this out, which is our thought process here. Copy this part down. Okay, now there's a common factor. The common factor here is 2 to the 2x, 2 to the power of 2x. So we're going to remove that common factor, factor it out. So 2 to the power of 2x. And remember, when you factor, what's left goes in brackets, and what's actually happening there is each of these terms is going to be divided by what we're factoring out, and what's left goes in here as an individual term. So here we have 2 to the power of x, and here we have subtract 5. And this is all equal to 0. Now we can use the null factor. Okay, so remembering the null factor tells us that if a times b is equal to 0, then either a or b has to be 0, or both of them have to be 0. It's the only way for this equal sign to be true. So we're thinking about that. So here we have 2 to the power of 2x has to be 0, or 2 to the power of x subtract 5 has to be 0. All right, we know from understanding exponents that this part here is not possible. There's no possible exponent we can put with the base of 2 that will give us 0 as an answer. Not possible. All right, so let's move to our other side and finish solving. So 2 to the power of x equals 5. All right. Several ways of finishing solving this now. You've got several tools you can use. You get to choose what you're using. In the textbook for this example, they use the change of base rule. Okay, so changing it from an exponent statement to a log statement, we could do that. So log base 2 of 5 is equal to x, and then x is equal to log base 10 of 5 divided by log base 10 of 2. Okay, so really, this is a legitimate answer here. That's an exact answer. Okay, they asked for an exact answer. This is a good answer. This is also a good answer. If you decided to change that to a log base e, we'd have x equals ln 5 divided by ln 2. If it didn't ask for an exact answer, we would then poke that in a calculator and give a rounded decimal number. And there we have it.